Greetings to all in Dr. Abha Chemistry Pathshala. So let us continue with our journey of chemical properties of carbonyls. So we are done with nucleophilic addition reaction of carbonyls, and you can see the flow chart. We have oxidation, reduction, reaction due to presence and absence of alpha hydrogen, and we have substitution electrophilic of aromatic carbonyls. So in this video we are going to talk about the oxidizing agents and the oxidation reactions of the carbonyls. So as you know, the carbonyls, they can get oxidized to acids, but oxidation of aldehydes and ketones, it takes place in a very different way, because in ketones a CC bond is to be broken, which is little difficult, so requires higher temperature. So without wasting time, let us quickly dive onto the class. So over to the screen for oxidation of carbonyls. Oxidation of carbonyl compounds, that is the oxidation of aldehyde and ketone. The aldehyde and the ketone group, they both will consume oxygen to go to the next higher oxidized form, which is acid. Now the question is, which acid we get? In aldehyde we get same number of carbon atom acid. If we start with 2 carbon atom left side, we reach with 2 carbon acid on the right side. But here we get different number of carbon atom, because the structure of CO is different than the structure of CHO. If you look at the structure of aldehyde and ketone, so for oxidation of aldehyde, we require this to become OH. So this is good. The bond CH bond will get oxidized, which is easier than CC bond. Here what we would need CO and OH, that is CC bond has to cleave. Here only CH bond has to cleave. So definitely the products are going to be different. This will give COH, giving you the same number of carbon atom. Here there has to be a cleavage. So the product are going to be more than one, and both will have different number of carbon atoms and the reactants. Suppose this has got a 3 carbon, so we will get 2 carbon and 1 carbon acid. Let us talk about some common oxidizing agents for aldehydes. We know aldehyde forms the same number of carbon acid as which are present in the aldehyde. So the common oxidizing agent are dichromate in acidic medium, KMnO4 in acidic, alkaline or neutral medium, chromic oxide in Conquest SO4 known as Jones reagent. We can go for Tollens reagent test, which gives acid. Fellings reagent test also will give acid for only aliphatic aldehyde. Iodoform is only true for acetaldehyde. No other aldehyde will give iodoform positive, where aldehyde gets converted to acid salt. With KMnO4, K2Cr2O and Jones reagent, these are the way the reactions are written, but with acetaldehyde we get acetic acid. With formaldehyde we get formic acid, which gets converted into CO2 and H2O. If we take Tollens reagent, which is exclusively for aldehydes, aliphatic as well as aromatic, we get diamine silver with basic medium, which will give us acid salt, silver mirror and ammonia. So silver mirror can help us test the presence of aldehyde. So this can be used as a test for presence of aldehyde. Let us prepare Tollens reagent. We prepare Tollens reagent by adding ammonium hydroxide to AgNO3. So we call it ammoniacal silver nitrate, which gives us Ag2O, which reacts with excess of ammonium hydroxide to give us diamine silver and OH minus. So let us write Fellings test, in which we take, in basic medium we take cupric ions, which give us acetic salt, Cu2O and water. Fellings reagent has got Felling A and Felling B. Felling A has got copper sulfate, Felling B has got sodium potassium tartrate, which is also known as Rochelle salt. Last oxidizing agent is iodoform test, in which I2 and NaOH. NaOH can be taken as dilute, NaOH can be taken as conc, only the balancing will be different. In both the cases we will get sodium hypoiodide. Aldehyde has got CH3CO. You want to go through the detail of iodoform test? You can see the link in the I button. That's a very good test. Iodoform. You can go through this link to see the types of aldehydes, ketones, alcohols which show this test. So we get again the salt of acid. Please mind it, If you start with 2 carbon here, you will get 1 carbon for acid and 1 carbon you will get iodoform, which is the main product of the reaction. That the reaction of ketone, oxidation of ketone was difficult due to CC bond cleavage. Hence, we will always see that the oxidation is only possible at elevated temperature. With iodoform also, you need to heat it, and the products are going to be little different than aldehydes. Let us look at the reactions. If you take KMNO4 or K2Cr2O7 at very high temperatures, you will get acid, but the acid number is lesser than the starting point because it will cleave from CC bond, and this cleavage will follow Popov rule. Unsymmetrical ketones. For unsymmetrical ketones, CO goes to smaller alkyl. CO goes to smaller alkyl. So this CO will go to this smaller alkyl, not to this larger alkyl of 2 carbon. So we will get 2 carbon acid from this side, 2 carbon acid from this side, we get ethanoic acid. In this propanone, again, this is a symmetrical, it can cleave from any place. So let us show cleavage from here. So we have 2 carbon acid and we have 1 carbon acid, formic acid, giving us H2O and CO2. Look at the iodoform reaction, we have acetophenone. So this has CH3CO, so iodoform test will be positive. This part will give same number of acid salt. So that was all about the oxidation of aldehydes and ketones. Hope to see you in the next class with some interesting topic of aldehyde and ketone. Take care. God bless.